Okay, thanks. I think I'm frozen. Okay, there we go. Thanks for your patience.
Yes, ma'am.
Something's going on with my internet here. Okay. So, how are you and what can I do for you?
I'm fine, ma'am. Actually, I wanted to just be in the meeting to see anything that you would review because I was doing the homework, the online homework, and I know you said in class Tuesday that we're gonna talk about strings on Thursday tomorrow. So I just wanted to see anything that you were gonna review so I can be prepared for tomorrow's class.
Okay, if I said we were going to talk about it tomorrow, I misspoke. What I was trying to say is that you have one question in your WebAssign on section 1.2 about strings. So we could talk about strings over O's and ones if you'd like to do that to help
Yes.
you with that one problem. Okay. All right. So let me just pause the recording and I'm going to point the camera to the paper. Give me the recording. We can start the recording again. I'm going to pin this so that it's the largest thing that we see. And I want you to help me check the focus. Welcome to office hours. How does that look?
It
It's
looks good. It's
great.
clear. Yeah.
Oh, fantastic. Thanks for your patience. Okay, so today is the 4th. Oh my gosh. All right, so strings over I'll call it alphabet. A equals O and 1. All right. So a string over an alphabet can have any length n greater than or equal to 0. There is such a thing as the empty string. So the empty string doesn't have any letters. In this case, the letters are the two binary digits at all, and we denote it with lambda.
All right.
But a strings of length 1, so if the string is length 1, then the options are it could just be an O. That's one of the strings of length 1. It just has one digit, one letter, so to speak, from the alphabet, or 1. Okay?
So the string is each number after the period. Sorry, the I don't know the name again. The comma.
Yeah, there are two different strings.
So those are
So
two
the
string.
so the number of strings, well, of length empty, there's only one string that's empty, but there are two strings of length 1. Let's think about
Mm.
strings of length 2. Well, it could be an O followed by an O,
Mm.
or it could be an O followed by a 1. Now that's a couple of them. Remember, we're building strings of length 2, so we get to choose the first digit. We have two choices for that. And we choose the second digit. We have two choices for that. So how many strings do you think we should be able to find of length 2?
Oh, then two we should be able to find. Um.
All right, let's think about it. We're going to choose the first digit, or, choose the first, you know, I'll just call it a digit. Sometimes we call it a letter. And then we're going to choose the second digit. How many choices do we have for the first digit if our alphabet has two values?
Zero.
Well, 0, O is one of the two alphabet values. Okay, these are the digits, right?
Mm-hmm.
Oh, but we could pick the O, but we also could pick the 1. We have two choices.
Mm-hmm.
Then when we choose the second digit, we still have two choices. We can use an O or a 1. So we should be able to find four strings altogether. Here I've written the two strings that start with O, but we have two other strings. Those strings would start with the one. So it could be a one followed by an O, or it could be a one followed by a one. These are the four strings of length two written over the alphabet we call it the binary alphabet. We call these bits. Does that
Mm-hmm.
make sense?
I'm not gonna lie, I'm quite confused. I'm trying to understand. I'm
Well,
sorry.
no, no, it's fine. That's why we're getting together. Um, let's just try strings of length three. Okay, we'll have a first digit and we'll have two choices for the first digit. It'll be an O or a one. And then we'll have two choices. Here I'm counting the number of choices.
Mm-hmm.
Uh, two choices for the second digit. It could be an O or a one. And then we'll have two choices for the third digit. It could be an O or a one. So strings of length three, well, O is one of them.
Oh, so a string is basically the first group of numbers before the comma.
Yeah, that's right. So um, this is,
Two string.
this is string
Okay.
one.
One.
This is string
String two.
two,
Okay, okay, okay.
three, and four. Okay.
Okay, okay,
So
okay.
here's string one.
And that has three, and the length of the string is three.
That's right. The length is three.
All right. So now we have A equals string 0 and 1.
Yep. So it could be 001. That's a string of length three. See,
Mm.
these are the two strings that start with two O's.
Mm-hmm. Using the numbers that were given, right?
Yeah, we're only using O's and ones
We can only use 0 and 1.
because that's our alphabet. That's right.
All right.
And we should be able to get eight strings all together because there are going to be eight different ways to concatenate these digits
Mm-hmm.
until we have three of them lined up. So here's four, there were four strings of length two.
Mm.
Okay. But see, we have four strings of length two, but we're going to get eight strings of length three because we could also have O
1 0.
one O, or we could have O one what?
Oh, one.
Yep, that's four of them, but we're going to find eight. These all started with O, you see?
Mm-hmm.
But what if they start with a one? It could be one
Mm.
O. Now I'm just going to change this O to a one, and we'll get four strings that start. I'm sorry, is there a TV on in the
Oh, sorry.
background? It just makes it really hard for the closed captioning. In fact, let me make sure I've got closed captioning set. Let me just look at my captions. Okay. Ah, so now we're seeing the captions. So now there are going to be four more strings, but they're going to look a lot like the first four, except instead of an O for the first digit, these will have a one for the first digit. So it could be 100 instead of 000. 10,
101.
good. Keep going.
110.
110, uh-huh.
And 00. No, no, no. 110. No, 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 no. 111.
Perfect. You got it.
Okay,
So that's
so
strings of length three. What about strings of length four?
4. But hold on.
How many will there be?
Oh, okay. It would be 2 times 2 times 2 times 2. That would be like 8 8 times 2, 16.
Yeah, there are 16 different strings of length 4. 2
Okay.
times 2 times 2 times 2 equals 16 strings.
16.
All right,
Okay.
so O, 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 O would be the first one.
Oh,
And then the last one is going to be 1, 1, 1, 1.
okay.
But there are a bunch of them in between because we're going to find 16 strings. So
Mm-hmm.
if we do it lexicographically, it means you keep the first digits as long as you can. So right now, if we keep the first three digits just the way they are,
We can
we,
just change the last one,
that's
basically.
right. And
Okay.
these are the two strings that start with three O's.
Mm-hmm.
Okay, they both start with three O's, but this one ends in an O, this one ends in a one. So now we have to start changing the third digit. So O, O, 1,
One,
O.
one.
Oh, yeah, and then O,
Oh,
O, 1, 1.
so
So
they
those,
always have to be different numbers for the 16 numbers that we're gonna do?
yes. Yeah, the sequences all have to be different from the other ones. We want to find all 16 different strings.
Oh.
And now, instead of changing the third digit from O to 1, we'll look at the second digit and we can have O, 1, O, O.
Mm.
Or we could have O, 1, O, 1. Or we could have O, 1, 1, O. Or we could have O, 1, 1, 1. I'm just sort of doing it in order.
Mm-hmm.
Does that make sense?
Yes.
Let's see. Then 1, O, O, O. This is the first string that we've written that has 1 for the first digit. In fact, do you see these 8 strings? They all started with O, but they're all different, right?
Mm-hmm.
Well, the next 8 strings, because we're going to get 16 altogether,
Yeah,
are going to look just like these,
but
except
with
that,
one.
oh, right. So we'll just follow what we did. What would the next string be?
1000.
We did that one. I mean, I already
Oh,
wrote
sorry.
that down, but
1001.
uh-huh. And we usually call the zero an O since it's
Oh,
binary.
yeah. Oh, okay.
You're fine. I just thought you might want to know.
Yeah.
All right, how about the next one? Instead of an O,
1010.
okay,
1011.
good. Keep going.
1100. 1101. 1110. And 1111.
Does that make sense?
Yes.
So, there are different games that we can play with strings of a given length. For example, if we look at all the strings of length 4, there's 16 of them,
Mm-hmm.
over this alphabet that just has O's and ones, we might be asked to find the set of all strings of length 4 over this alphabet that only has O's and ones that have exactly two ones. Maybe I'll write the letter, I mean the word two, have exactly two
Two
ones.
ones.
So we would look at this set of the 16 strings of length 4.
And select all those that have two ones in there.
That's right. So our answer is going to be we'll call it a set S for strings. You help me find the ones that have exactly two ones.
0011.
Yep. Oh, oh, 1, 1.
0101.
Good.
0110.
Good.
1001.
Good.
1010. 110. And that'll be it. I think.
I think you're right.
Okay.
So 1, 2, 3, 4, 5, 6. So 6 out of these 16 have exactly two ones.
Mm.
We could characterize this subset of this set a different way. We could say these are the strings that have exactly two O's. Because if they have two
Oh,
ones, they have two
2-0.
O's,
Yeah.
right? And
Yeah.
right. Another game we can play is all the strings of length 4 that have three or four ones.
3 or 4. Oh, yeah. Okay.
Let's play that game. Let me get some fresh paper. My closed captioning is in my own way. Let me just, I'm going to move. I want to move this down. I see. I can put this anywhere I want. I'm going to put my closed captioning up here. Can you see the closed captioning too? Can you
On
see?
my screen, I'm using my phone, so maybe that's why, but I don't see any captions.
Okay,
Or maybe
that's
I need to
fine.
turn it on. Maybe I don't know.
So that's fine. All right, example 1B. Let's find all strings of length 4 over the same alphabet, O1. I'm going to make it a little easier, that have fewer than two ones. So fewer than
Fewer
two
than two
ones.
ones.
So what does it mean to have fewer than two ones?
That means have like 3-0,
Or four O's?
4-0.
Because
That means
fewer
no
than
one.
two ones, this means 1 1 or no ones, right? Because if it doesn't have any
Fewer.
ones, it's got fewer than two. Do you agree?
So only one.
1 1 or no ones.
Oh, but so if we say fewer than two ones, that means we can use those that don't have any one.
Well, isn't having no ones fewer than having two ones?
Fewer than two ones.
Fewer than two
Anything
means
smaller than
one
two.
or
No
or
one.
none, right?
Oh, okay.
Because none is fewer than two. All
Yeah.
right, so we'll call this set T. All right, we want fewer than two ones. Well, what's going to go in there?
We're gonna put 001.
0 0 1 is a length 3 string. We want to draw from the length 4 strings.
Yeah,
We're going
it's
to draw,
0000.
yes. Oh, oh, oh,
Oh,
oh.
oh, sorry, yeah.
That's fine. It
Oh,
has no ones. And it's the only string that has no ones. So this is it for that. Now we'll look for the strings that have exactly one one.
001. 01.
Oh, 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 one. Uh-huh.
0010.
Good.
0100.
Good.
And I think that's the last one. Oh no, 1000.
Yep, you found them. So there are 5 strings like that. And these strings that have fewer than two ones have two or more O's,
Mm-hmm.
right? Notice
Yes.
we could describe set T as the set of strings of length 4 over this alphabet, the bit string alphabet O1, as the strings of length 4 over the set containing 0, 1, having,
Fewer than two ones.
which means having 2 or more ones, O's, excuse me. These have 2 or more O's. If they have fewer than 2 ones, it means they either have 1 or no ones, which means they have, 3 fewer than 2. So it could be 2, no, 3 or more O's. Yep, these are the ones that have 3 or more O's. This one has 4 O's, and these other ones all have 3 O's, right? Because if the string has 1, it's got 3 O's. If the string has no ones, then it has more than 3 O's. It's got 4 O's. Does that make sense?
Yes, it does.
So I think one of the WebAssign problems is about strings over
Yeah, that's the last one on
alphabet.
the homework.
Problem 5.
I think so, yes.
I think so. In WebAssign.
Yeah,
So you can see the WebAssign for section 1.2, problem number 5. I think it is the last problem. I think there are only
yeah,
5
it is
problems.
the last one.
Great. Does that help?
Yes, thank you. That was what I had an issue with. I wanted to ask because I couldn't understand what was in the book either, so I was like I need to like know how to do it. But yeah, that was all. Now I know, so let me go try do it.
Okay.
All
Can
right.
I can I help you with anything else?
No, that was all for now. Yeah.
That's fine. Okay. Well, you're welcome to work on your WebAssign here in the room, or you're welcome to leave. I'll pause the recording until somebody comes in.
All right, ma'am. See you tomorrow.
See you
Bye.
tomorrow. Bye. Like you can take the answer from here, but
Yeah.
it's not a bad idea to try to figure it out on your own.
All right.
See what I'm
Oh,
saying?
it's actually wrong because here it says contains three or more ones. So it's actually the total opposite.
There you have it.
All right, let me go work on it by myself then.
Okay, perfect. And so now I'm practicing being logged in with my iPad so you can see my face, as well as being logged in with my PC and the camera that points at the picture of the notes. And it looks like it's working well. I'm going to pause it now. Well, no one else is coming to the office hour, and it is about 7:58. So I'll close our office hour now, and I'll see you tomorrow in class. Thanks for playing.